All right, moving on to multiplying polynomials, module 18. So to multiply polynomials, you need to be familiar with the product rule. Yesterday, when we added and subtracted polynomials, we needed to make sure that the variable or variables were raised to the same power, and if they were, we just combine like terms. For example, if it was 5x squared plus 4x squared, all we would do is worry about the coefficients, which are 5 and 4, add those two, but leave the exponent the same. We did nothing with the exponent. With multiplication, it's going to be a little different. We're going to have to use the product rule. And to explain the product rule, I first want to discuss what a power actually is. For example, if we have 3 to the third power times 3 to the second power, what is that really? Well, remember, exponents and powers are just repeated multiplication. So that's the same thing as saying 3 times 3 times 3, and that would be that 3 to the third power, times this right here, which is 3 times 3, which gives us, well, we have 5 3s, so that turns out to just be 3 to the fifth power. So what did we really do with these two exponents? We just added them. 3 plus 2 is 3 to the fifth power. So the same goes with variables. Even though we don't know the value of a variable, if it's the same variable, like x to the third times x squared, that's just x times x, which is that x to the third, times, then this x squared would be x times x. So if we count all the x's there, it's really just x to the fifth power. We're multiplying x by itself 5 times. So the product rule is basically just that. When you have, let me erase all this. When you're multiplying two powers, like a to the n power times a to the m power, okay, all you are going to do is keep the base the same, a stays the same, but add the exponents. So let me do an actual example with some numbers instead of n and m. If it's y to the fifth power times y to the seventh power, all you need to do is keep the base the same, it'd still be y, and then 5 plus 7, which would be 12. It would be y to the 12th power. That's the product rule. When you are multiplying a monomial, or two monomials, you need to remember the product rule, which is just adding these. Let's do some examples. So here we have x times x plus 4. So if we're going to multiply this, we're going to use a distributive property. So it'd be x times x, and then x times 4. Well, for x times x, you need to remember the product rule. And that's the same thing as saying x to the first power times x to the first power, which would mean x to the 1 plus 1 power, which would be x squared. We add the exponents. We add the exponents. So x times x is going to be x squared. Then x times 4, it will just be 4x. And that's how you would multiply a monomial with a binomial. Here's one that's a bit more difficult. So here we have 5r squared s squared times negative 2r. Remember, you can only multiply those variables that have the same value, that have the same base, the exponents have the same base. So first, for the coefficients, you're just going to multiply the two coefficients. 5 times negative 2. That's negative 10. Then for r squared, it's r squared times r squared. I'll do that on the side here in red. R squared times r squared. With the product rule, that would mean that we would add those two exponents, 2 plus 2, which would be r to the fourth power. So here we'd have negative 10r to the fourth power. All right. Now we have this s squared here, but this first monomial did not have an s squared, so we would just bring the s squared down. We didn't do anything with it. Now we continue our distribution, or we continue using the distributive property. So now we multiply 5r squared s squared times 3rs. Well, first you would just multiply the coefficients, so it would be 5 times 3, which is positive 15. Then r squared times r, that's the same thing as saying r squared times r to the first power. You would add the exponents, so that would be r to the third power. R to the third power. And then s squared times s, again, you would add the exponents, so that would be the same thing as saying s to the third power. All right? And then we continue using the distributive property, and we multiply those last monomials. And if we do that, it would be, we multiply the coefficients first, so it's 5 times negative 4, which is negative 20, right? And then it's r squared, well, they're There is no r in the other monomial, so we're just going to bring down the r squared. But we do have s squared times s squared. Well, what's s squared times s squared? If we use the product rule, we would just have to add 2 plus 2, which is 4. It would be s to the 4th power. So your final answer would be this right here. And that's how you would multiply monomials using the product rule. Let's do another one. This one's a little easier than our last example, but if we use the product rule, we'd have to multiply negative 2x times 3x. First, we would just multiply the coefficients, which is negative 2 and 3, and that gives you negative 6. Now, to multiply these two variables, x times x, you would need to use the product rule. So it would be x to the 1st power times x to the 1st power, which is x to the 2nd power. We add 1 plus 1. So that's negative 6x to the 2nd power. We distribute again. Negative 2x times negative 4 would be positive 8. And then the negative 4 does not have an x, so we're just going to bring this x right here down. And then don't forget about this part right here, which is plus 7x. So now we are going to go ahead and see if we could combine any of these monomials. See if we could add these monomials together. And we can. We could add 8x and 7x and simplify this even further. So that would change this to negative 6x squared plus 15x. That would be your answer in standard form and simplified. Let's do one more example like this. Take a look at this one. So here we have addition, we have multiplication, we have everything. So the first thing we're going to do is get rid of the parentheses. We're going to get rid of these parentheses first that are inside the brackets. So we distribute this negative 5, and I'll do this in red, to each of these terms on the inside. All right. So I'm going to rewrite the stuff that I'm not working with yet. I'm not doing anything with the 4b yet. I'm not doing anything with the 2a squared yet. But negative 5 times 3ab, that would just be multiplying negative 5 with 3 and bringing down the ab because this negative 5 here, this term doesn't have an a or a b. So that would just be negative 15 ab. And then negative 5 times negative 2b squared is just multiplying the negative 5 and the negative 2. That's going to be a positive 10 ab squared. And then that's plus 29 ab squared. I didn't do anything with that. Now I'm going to have to use distributive property again, and here's where the product rule comes in handy. First, we're going to multiply 4b times 2a squared. Well, we have a b and an a squared, so we're not going to be able to actually do anything with that because in order to use the product rule, the bases must be the same. We have to have the same variable. We can multiply the 4 and the 2. 4 times 2 is going to be 8, and then just bring down the stuff that we didn't multiply, a squared, or that we couldn't simplify is what I meant to say, a squared and b. Next, we're going to multiply 4 times negative 15, which is going to be negative 60. Now, I'll do this in yellow. This monomial here has an a, whereas this one does not. So I'm just going to bring the a down. However, we can multiply the b's. b times b would be b squared if we add 1 plus 1. And then your last one here is going to be 4b times 10ab squared. So again, just multiply the coefficients. That would be plus 40. We have an a here that we don't have here. So we're just going to bring the a down that we couldn't simplify any further, or we couldn't use the product rule with. And then we have this b here that we're going to multiply with b squared. So that's 2 plus 1, which would be 3. So that would be 40ab to the 3rd power. And we just bring down the plus 29ab squared and combine like terms. It looks like we can combine some like terms here. We have negative 60ab squared and positive 29ab squared. And that looks like the only term that we can combine. So if we combine that, we have 8a squared b minus 31ab squared plus 40ab to the 3rd power, and that's about all you'd be able to do. And then because you wouldn't be able to combine these any further because they don't have the same powers. Remember, in order to add polynomials, they have to have the same variables raised to the same power. And I think that's where we're going to stop. So make sure you have taken great notes. Make sure you have all these examples in your notes. And we'll talk more about this tomorrow. Have a great day.